Hi, this is My Career Journey by Jason Rodriguez. Why race engineering? Well, I chose race engineering because I've always wanted to be involved in motorsports and the engineering behind the race cars. Race engineering is interesting to me because it's the most challenging, exciting part of the team. They have to set up race cars to the best performance. They overlook a lot of categories within the team and they communicate to the drivers. With this job, it requires a lot of characteristics which I feel I have because I have a lot of years with teamwork, discipline, and I have persistence, determination, and I work good under pressure. And this career aligns with my goals of creating the best future race cars, winning championships, and having a job that's fun. Now, work environment. It's not your typical cubicle or office job, but most of the time you're traveling between countries at months at a time. Most of the work is done between computer labs with other engineers collaborating in simulator rooms, conferences, or meetings, and you're moving around most of the time. And when it's the off season, you're either going to the shop or main facility or factory where the car's being constructed, always checking over the parts, and it involves a lot of teamwork. Job growth and outlook. For race engineers, there's not a lot of information about it, but based off mechanical engineers, there's expected between 2020 and 2030 a 7 to 8% increase, or about 20,900 jobs opening up, with a median salary about $90,000, reported by the USnews.com. The unemployment rate of mechanical engineers is about 4%. I provided some graphs and charts to look over to give some more emphasis on this growth. Now, career technology. Race engineering has a lot of complex technologies that go into it, but a lot of it can be learned through university graduate classes, workshops, or clubs. Some of these technologies include CFD simulations, three-dimensional modeling, and computer-aided design or CAD. In addition, data analysis acquisition, which is a top software used for strategy, and getting data from the cars. Race engineering also uses many programs such as MATLAB for calculations and charting data, ANSYS, Siemens, or Haltech for tuning and research and development, or R&D. These programs need high-rated computers in order to run them. And finally, simulators are used to gather data from drivers, use their driving characteristics, and apply them to real-world instances and get the best performance. Projected changes in career technology. Now, technology within the motorsport and engineering industry is always updating each year, so eventually AI technologies will further improve accuracy and the experiences for these programs. This is the case with computer-aided design softwares where AI will be introduced to enhance the experience, make the design process faster. Computational fluid dynamics or CFD simulations showing real-world effects on the parts in the cars will be more accurate due to new algorithms and physics integrated within the systems. And simulators for drivers will incorporate the feel of real race cars more and the effects while driving them, providing more accurate feedback to engineers to use. And the factories will gain better materials, producing better quality parts and sensors for the cars, giving more reliability, performance, and accuracy of feedback. How my major can prepare me for my career. Mechanical and race engineering have many requirements in common to work within the automobile and motorsport industries. Mechanical engineering provides many transferable courses and classes that are needed, like computer-aided design or CAD, computational fluid dynamics or CFD, basic programming, physics and math courses, or elective courses that can be applied towards motorsports. Many engineers in motorsports either have a motorsport or mechanical engineering degree, which are virtually similar with the same classes and certifications needed. However, the only way that my degree does not prepare me for my career is track experience, but it can be completed through internships and master's degree programs. New findings about race engineering. Here are some interesting facts that I researched about race engineers that I didn't know. Some race engineers go through the ranks by applying as pit crew mechanics, and they gain their master's degrees in mechanical engineering during the job process, getting track experience and trust in the team to eventually get their titles. Race engineers form close bonds with their drivers and are constantly communicating with them, spending most of their time together during the season. Race engineers take part in crucial decision-making processes during the races and are always suggesting to drivers and crew chiefs. The work that engineers do is very fast-paced, requires a lot of time, effort, and travel within a certain number of races, and race engineers can connect with fans, sign autographs, and inspire others that want to take part in motorsports in the future. Gaining experience at FIU or communities for my career. Getting experience within motorsports and engineering at FIU has been pretty easy. At FIU, they offer many clubs like Formula SAE Panther Motorsports, which is a competition-based club that can give many opportunities to its members. Some of these opportunities include internships within the automobile, aerospace, and aeronautics industries, or even jobs once graduating. Having this club on resumes is an advantage for engineers, and it helps through the job-seeking process. Having been a part of this club for about 4 months, I can personally say I learned a vast amount about motorsports, industries, and engineering. Other communities that can help undergraduates like me gain experience in motorsports is a local racing league called FARA, or the Formula and Automobile Racing Association, that houses events at Florida's local tracks that have amateur teams and are willing to invite new engineers or drivers so they can begin their motorsports careers. Finally, Handshake versus LinkedIn. Three differences between each other is that Handshake is a platform used by university students seeking to apply for jobs, internships, apply for workshops, or browsing for future reference, while LinkedIn is a social media platform used by employers for the profession seeking out candidates for their job openings. LinkedIn provides experiences to students to build relationships within the companies to eventually form their professions, while Handshake focuses on the future of the university students, providing services and internships so they can directly jump into the job they want and keep on getting success after. Handshake is solely focused on university students, while LinkedIn is open to all and is basically public. Three similarities is that both platforms have the ability to provide opportunities and jobs and how to get them. Both platforms can connect potential employees to employers and build connections. And both platforms are free to users and are offered as apps on mobile devices, making it easier for potential employees to find a job. But the benefit of both LinkedIn and Handshake to me as a student is giving me opportunities at hand, suggesting workshops that fit my career path and job openings that fit my interests. They both connect me to internships, companies, and experiences and try to get the most out of my skills, resume, or previous organizations I've been a part of to display at any opening or internship that may come arise. In short, these two platforms are the best ways I can find a job in line with my interests and skills and can lead me to the profession I've been wanting. Again, this is My Career Journey by Jason Rodriguez about race engineering. Thank you for watching.